So this is some extra help on proofs the Mr. Kirkton way. Maybe a little different than what you see somewhere else, but what I'm going to suggest that you do when you're thinking through these problems again, we'll go through the formal part here, but think about this informally. Cover up what you're trying to prove and just look at this picture and jot down some things. What do I know? I know it's given to me that angle 1 is congruent to angle 4. That's given. What else do I know just from the picture? Well, I know angle 1 and 3 are congruent because they're vertical angles. And I know 2 and 4 are congruent. Also vertical angles. I could say 1 and 2 are supplementary. By the linear pair postulate, 3 and 4, or 2 and 3, 3 and 4, 1 and 4, they're all supplementary. Any two in a row are supplementary. So I have all those ideas. Lots of stuff I can say is congruent or supplementary. So what am I actually trying to show? Trying to show that 2 and 3 are congruent. So the question becomes, can I somehow do a substitution to show that those two angles are congruent? So I already got my given listed, angle 1 and angle 4. And I go back here and look at what I wrote down. So as long as I can connect angles in a row, so I can say if 1's congruent to 3 and 3 is congruent to 4, that going that direction, or I can say since 1's congruent to 3, 1's congruent to 4, I have the angles I need between my given and right here. I have the stuff I need, so I'm just going to transfer my. So angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, and that was vertical angles theorem. Some of you are writing VAT. That's okay for now, but I'd like you to write out the words. All right, so look at this chain of events here. Let's see. We want to get to see that 2 is congruent to 3. So I know 1's congruent to 4, which means it's also congruent to 2. Right? So since that is given, angle 1 is congruent to angle 4. Don't write this down yet, which means it's also congruent to angle 2. Because I can go from one to the next to the next. Well, I also have a statement here that says angle 1 is congruent to angle 3. How could I use that? Angle 1's congruent to angle 4. There's another little trick there. Angle 3 and 4 have to be congruent. Is there any way I can make a combination to get from 2 to 3? Well, let's just keep going here. Angle 1's congruent to angle 4, which means we're congruent to angle 2. And I know going to stop at that one. So basically by the transitive property, because when we're going in order like that, I can say angle 1 is congruent to angle 2, because angle 1 is congruent to angle 4, angle 4 is congruent to angle 2. So angle 1 and angle 2 are congruent. I need to show that angle 2 and angle 3 are congruent. Well, if angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3, I could substitute angle 2 for angle 3 and have my statement. Now, it seems a little cluttered what I'm saying right here, okay? Because I'm kind of thinking out loud. But the transitive property is really doing substitution twice. We start out with 1's congruent to 4, and then we take and put something else in there. And then we see 4 is congruent to 2, we take and put something else there. So your steps can really follow, these three things lead to this, and then I just do substitution from there. It's not going to be pretty, it's going to be messy at the beginning. Okay, so I have this picture. Angle A is congruent to angle BDA. So first thing I'm going to do is mark my angles on here. So this is angle A, and angle BDA is that. So we know that. What can we prove? Well, if two angles are congruent, we could set them equal to each other. So one thing we could do is set 11x plus 20 equal to 12x plus 15. If angles are congruent, then we can set them equal to each other. We could also show that BDA is congruent to CDE. We could also use that because of our vertical angles theorem. So we can find out lots of stuff. Once we find x, we can plug it back in, we can find all the angles. So it doesn't say what you could prove. You could solve for x. You can find any of those missing values. So I'm going to go ahead and just solve this for x just so we have it on here. So we subtract 20 from both sides. X equals 5. So I go and plug that back in. Now I got all kinds of stuff I could do. 5 times 11, 55, that's 75. 5, so 60 plus 15, 75. We know CDE is 75. 75 plus 75 is 150. That means you'd have 30 there. We haven't done triangles yet. There's lots of things you can do there. Last one, partner practice. This video's getting a little long here. So again, thinking through this, cover up what it says you're trying to prove. What do I know here? Well, I know that all the vertical angles are congruent. So I could list all those. 2 is congruent to 4. 1's congruent to 3. 5's congruent to 8. 6 is congruent to 7. Any one of those I could use. I'm not going to use all of them. What are we given? We're given that 5 and 2 are congruent. So which of my little equations here have to do with 5 and 2? That one and that one have a 5 and a 2. So we're given those two are equal. So I'm kind of adding those into my thinking statements. So look how this might work. If 5 is congruent to 2, 2 is congruent to 4, so 5 is congruent to 4. If 2 is congruent to 5, 5 is congruent to 8, 2 is congruent to 8. So I think it's either going to ask me 2 is congruent to 8 or this 2 to 4 business. Oh, we got 8 to 4. Let's look and see. So, surprise. Can we show that? So, I'll let you write the given. And you need to do that. I'm just saving time on this video so you don't fall asleep. Step 2, list your stuff. I need to show that 8's congruent to 4. Well, I know 2's congruent to 4. And I know 5's congruent to 8 because of the vertical angles theorem. So I use my two things here. I also know 5 is congruent to 2. So if 5 is congruent to 2, that means I could say that 5 is congruent to 4. Substitute. And I could say 5 is congruent to 8 is already there. If 5 is congruent to 8 and 5 is congruent to 4, then angle 5 is a common angle. So angle 8 is congruent to angle 4. And if you want to put that into a chain, you can. The chain is angle 4 is congruent to angle 5. Angle 5 is congruent to angle 8. So therefore, angle 8 is congruent to angle 4. You put them in a chain, that is the transitive property. That's all she wrote, folks.